Alright, so what we're going to be covering today is the process of forming ionic compounds through a metal atom that's going to be losing electrons and a non-metal atom that's going to be gaining electrons. So we have two atoms here on the board. One atom that I've drawn is the sodium atom. And what I've shown is the nucleus with the 11 protons, the 3 energy levels, and then on the outside of the atom there's 1 electron, and that's because it's in column 1A. The shortcut for drawing the sodium atom is using the Lewis dot structure, where I put the symbol of Na and I put the 1 electron on the outside. So this atom of sodium right now contains 11 protons and it contains 11 electrons. Because this sodium atom wants to have a complete outer energy level, its desire is to lose this 1 outer electron. If we move over here to a chlorine atom that's located in column 7A, its symbol is Cl. The reason it's located in column 7A is it has 7 outer electrons. Because it has 7 outer electrons, we write its Lewis dot structure as having 7 electrons around the symbol Cl. Cl is a nonmetal. It already has 7 outer electrons, so its desire is to gain 1 electron. Currently, the atom of Cl has 17 protons as well as 17 electrons. As mentioned, an ionic compound is a process that occurs where a metal atom is losing electrons and the nonmetal atom is gaining electrons. And so what happens is this Na with 1 outer electron loses that 1 outer electron over to chlorine. And we say that what happens is an exchange of electrons. Once this occurs, the sodium atom no longer has the 11 electrons, and now it only has 10 electrons. To show this process here with the Lewis dot structures, we would circle one of the outer electron for sodium and show that it's being exchanged over to chlorine. Because sodium now has 11 protons, that didn't change, but it now only has 10 electrons. It has a charge to it. And so we have to put a 1 plus, and in chemistry, whenever there's a 1, we typically leave it off, so we put an Na with a plus. So that sodium atom has changed into what we call a sodium ion, a positive ion. Over here, the chlorine atom gained an outer electron, and so instead of having 17 electrons now, it has 18 electrons. So now it's got 1 more negative charge than it has a positive charge. And so we have a Cl with a minus. Now these atoms turned into ions, and these ions are oppositely charged. And so what we end up with is a repeating pattern of positive and negative ions that form an ionic compound, all based off the number of outer electrons that they start with and that they want to end up with. So we're going to continue our conversation on ionic compounds where metal atoms are losing electrons and non-metal atoms are gaining electrons. Here we have an aluminum atom that's a metal with 3 bonding electrons. The atomic structure shown here and the Lewis dot structure shown here. These 3 bonding electrons are represented by the shortcut Lewis dot notation for 3 bonding electrons. This aluminum atom has 13 protons as well as 13 electrons. 13 protons in the nucleus and 13 electrons arranged outside the nucleus. Over here we've got the atomic structure for phosphorus, where we have 15 protons in the nucleus as well as 15 electrons located outside the nucleus in the electron cloud. Phosphorus is a nonmetal. It is in column 5A because it has 5 electrons in the outer energy level. And here's the atomic structure, and then we use a shortcut Lewis dot notation to represent those 5 bonding electrons here around the symbol. Aluminum is in column 3A, and that's why it has the 3 bonding electrons on the outside. As we mentioned, when we're forming ionic compounds, the metal atom is going to be losing electrons and the non-metal atom is going to be gaining electrons. In this case, though, aluminum's desire is to lose all 3 of those bonding electrons so that that last energy level is empty and it drops back to the second energy level, which is 4. For phosphorus being a nonmetal, having 5 valence or bonding electrons, its desire is to gain 3 electrons. So its outer energy level will have 8 electrons and be complete. And so what happens is aluminum takes all 3 of its bonding electrons and exchanges them over to phosphorus. We call that an exchange of electrons. And so what happens, no longer does aluminum have 13 electrons, now it only has 10 electrons. And because it only has 10 electrons, it now has 13 positives and only 10 negatives, the positives are winning by 3, so aluminum becomes a 3+ ion. A 3+ ion. The atomic structure, we show the exchange of electrons like that. And for the Lewis dot structure, we show the exchange of electrons similarly. For phosphorus, because it gained 3 electrons, we will cross this out and put an 18 here. We have 15 positive protons, but now we have 18 negative electrons. And so now phosphorus turns into a 3-. The metal atom losing electrons, forming a positive ion, and the non-metal atom gaining electrons, forming a negative ion. What I want to point out is that even though aluminum lost 3 electrons, there was only 1 aluminum involved. And even though phosphorus gained 3 electrons, there was only 1 phosphorus involved. So if we were to write the formula for this ionic compound, we would write it as Al, because there is only 1. We have an invisible subscript here as a 1, and a P, Alp, another invisible 1. And then its name would be aluminum, and we change the ending of phosphorus to IDE, and so it becomes aluminum phosphide. Aluminum phosphide. Once again, a metal atom losing electrons and a non-metal atom gaining electrons, forming positive and negative ions.